I am now recording. What have I given you? What is this?
Unit circle.
It's a what?
Unit circle.
It's like a gun thing.
It's an FFA.
Oh, okay. It's a circle. All right. Couple people just some advanced knowledge here. So this is a circle, okay, and it's got some points on it, right? And what are these right here? The vertical and the horizontal. What do we call those? Axes, right? And what's the horizontal? It's the x-axis, and the vertical is the y-axis. Very good. So we have the vertical axis is the y, and the horizontal is the x. So what are we going to do today? Well, we're going to start by figuring out some things about this circle. And specifically, we notice we have these points. What we're going to do in this lesson today is we're going to figure out the xy coordinates of these points. Okay? We're going to figure out the locations of those points. And as you can imagine, maybe getting this point or this point would be relatively easy. Right? I could figure this one out or this one. But these ones, they look kind of random. I don't know where they are at. Okay? So I have to figure out I have to figure out their locations. And the question is, how should I do that? How can I do that? Well, the first thing that we're going to start with is one property of the circle. And the property of the circle that we are going to start with is its radius. What's the radius of a circle? What is the radius? Does anyone tell me? Just define it. Halfway across, that's cool. Half the diameter, that's good, nice. Where does the radius usually start? At the center, good. And the center of our circle is here at this intersection of these axes. What's that point called? An O? Yes, origin. It's the origin. The origin is here, and the center of our circle is at the origin. Okay, so the radius of this circle is equal to 1. So we start with that. So we'll go ahead and write that on the top. So the radius of the circle is equal to 1, and we know the radius of the circle is the distance from the center to the circumference in any direction. Okay, so that's where we start. Now, everyone, please take out your protractor. If you don't have one, please take out. Hello, sir. Please take out a straight edge. Oh, Charlie. Where's Charlie? Right? Okay, Charlie, you are right there next to Sandy. Right there. Thank you, sir. Okay. All right. Okay. All right. Thank you, sir. How'd it go? Nice. Okay. So, the radius of the circle is 1. We are going to figure out the location of the points on the circle. How are we going to do that? That's a good question. You should have all taken out your straight edge at this point. Whether it's a protractor or something else, that's fine. Hopefully you guys have a protractor. If not, pull out a credit card or something that you can use as a straight edge because you're going to need it. You're going to need it. All right. Now, our first step. So you guys are going to follow my steps here. And I'm going to do my best. I want you guys to know that I came thoroughly prepared for this lesson today. Why is that? To glorify myself? No, it's to praise God. Look at this. I have 3 pages of notes for this lesson. That's right. Praise God. Amen. That's right. That's right. That's right. Okay. So, the first thing that we are going to do is we are going to draw a line from the origin, the center of the circle, to the first point. And if you have your protractor, you would be able to measure this angle that you make between the x-axis and you would be able to see that this is a 30-degree angle. So you're drawing a line from this point to this point. Yep. Yeah. Got a phone call. That's cool. All right. So what we're going to do right now is we're going to figure out the location of this point. All right? We're going to find the location of this point. But in order to find the location of this point, we're going to use okay? No, you're okay. It's all right. You're good. You're good. So, trigonometry. Trigonometry. What are the first three letters of trigonometry?
Try.
Try. Yes. So I hope you tried. That was good. I never thought of that. That's good.
Nice.
Nice. So, TRI. All right. What's a shape that starts with TRI? Triangle. Good. So in order to figure out these, we're gonna make some triangles. Okay. So draw that line, and now once you've drawn that line, go ahead and draw another line from the origin to the same point but in the negative. And before I continue, I should tell you that we're going to talk about quadrants in trigonometry. You guys remember quadrants? You know about quadrants?
Yes.
So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So go ahead and label those quadrants. 1, 2, 3, 4. And we always use Roman numerals for those quadrants. Probably because there's a lot of numbers anyway, so you might as well just use Roman numerals. That doesn't confuse you. Okay, so you've got your two lines there. Now, again, if you have your protractor, you'd be able to measure, and this angle is 30 degrees. Cool. Now, yes. The next step is you're going to draw a line and you're going to connect the 2 points together with one straight line, just like this. Now, what did we draw?
A
Triangle. But specifically, what type of triangle did we draw?
A nice
Technically an equilateral triangle, but we haven't gotten there yet. What do we know for sure? Well, let's think. What do I know? What's this side here? It starts with an R. It's a radius. It's a radius. From here to here, that's a radius, right? So how long is that side?
1.
1. Very good. And this also is a radius, so this side is also 1. So what do I know about those two sides? They are the same. Therefore, this is at least an isosceles triangle. If this is an isosceles triangle, what do I know about these two base angles? They must be the same. Very good. So I know these two angles must be the same, so I'll label them x and x. Now, I want to solve for those angles. I got to figure out what those angles are. What do I know about all three angles? What do I know about the sum of the interior angles of a triangle? They add up to 180. Very good. So, if I write this down, 30 plus 30 is 60. X plus x is 2x, so 60 plus 2x has to equal 180. And I can use this equation now to solve for x. I subtract 60 from both sides. Get 2x equals 180 minus 60 is 120. And then I divide both sides by 2. And I get x equals 60. X equals 60. Cool. So what did I just find? These angles are equal to 60 degrees. Nice. All right. So this angle here, I'll replace the x with 60. And this is 60 as well. So wait a second. This is 60, this is 60, and 30 plus 30 is 60. So all the angles are 60, which means they're all the same, which means what type of triangle is this? Equilateral. Cool. So if this is an equilateral triangle, what do I know about this side here? It's also 1. Very good. This side is also 1. But even though I'm interested in that, I'm more specifically interested not in this whole side, but if this whole side is 1, what's the distance from this point here to this point here? 0.5. Very good. Okay. So, now, I know the distance from here to here is 0.5. What did I just find out about this point? Well, let's think about this. The x-coordinate tells us what? How far it is to the right or left, right? The y-coordinate tells us if it's up or down, right? Well, I just figured out that this point is 0.5 from the x-axis, so 0.5 up. So what did I just find out? Y-coordinate is 0.5. Good job. Good job. All right. So the y-coordinate is 0.5. Nice. Now, what do I have to find next? The x-coordinate. Very good. I have to find the x-coordinate. So in order to find the x-coordinate, what I'm going to do, and you can do this too if you'd like, draw a line just kind of separating these two triangles. And it's already done by the x-axis, but it just makes it a little bit more clear. You just draw a line right through the center like that. And then we notice that I've got this individual triangle here, right? And I take a look at this. This angle's 30, this angle's 60. 30 plus 60 is 90. What does that make this angle here? 90. So that angle is also 90 degrees. That angle is 90 degrees, rather. So I have 30, 60, 90 triangle. I know that this side is 1, and this side is 0.5, right? Well, how do I find the third side? I've got a right triangle. Yes. I've got a right triangle. To find the third side, I use Pythagorean Theorem. And remember, when I do the Pythagorean Theorem, it's the leg squared plus the leg squared equals the hypotenuse squared. And the hypotenuse is always by itself, and the hypotenuse is the longest side opposite the right angle. Okay? So I set this up and I get x squared plus 0.5 squared is what? 0.25. What's 5 times 5? 25. 0.5 times 0.5 is 0.25. 0.25. So 0.25 equals, what's 1 squared? 1. Okay. Then I go ahead. Yes?
I have a question. When
Yeah.
you're squaring it, does it always necessarily have to make it a bigger number?
No, like in a decimal, for instance, a decimal will always become smaller.
Always?
Yeah, because a decimal multiplied by itself, every time it's making it smaller and smaller. Good question. So now I subtract 0.25 from both sides. I get x squared equals 0.75. What do I do now, class? To solve for x, square root. And I get x equals the square root of 0.75, which we can't really do in our heads. So we use a calculator, which is why you guys are going to need calculators. And we get 0.866. 0.866. Very cool. So what did I just find? I found the third side is 0.866. What else did I find? What did I figure out about that point? I figured out it goes up 0.5 and it goes over 0.866. This point here is 0.866 over and 0.5 up. See? So I found the x-coordinate of that point, which is 0.866. Bam. Got it. Okay? We figured out the coordinates of this one point. See? All right. Cool. Now let's move forward. Okay, first thought, we're using triangles to find out about points on a circle. Interesting. Right? Okay, cool. So you guys now have done that. Very good. Good job, Anya. Good, Anya, as they would say in England. So now flip over to the next page. I've given you multiple copies of this to keep it nice and clean, and so you don't get confused. Yes? Now, we figured out the location of that first point, so we're going to move forward, and we'll find the location of this point here. So just as we did the last time, we're going to draw a line from the origin to that point, and if you have your protractor, you'll be able to measure that this angle is 45 degrees. So it's a 45-degree angle right there. So go ahead and draw that line. And once you've done that, you're going to line your straight edge up so it intersects the points in quadrant 1 and quadrant 4. You see? So it's just like that. And you're going to draw a straight line down, but stop at the x-axis. So you're going to draw your straight line down, but stop at the x-axis. So it should look like this, just like that. Okay? Draw your straight line down, just like that. God bless you. And once you've done that, go ahead and finish off your triangle by drawing that straight line, just to make it clear. Okay, cool. Now, what is this angle right here? 90. So if this is 45 and this is 90, 45 plus 90 is 135. What's this angle right here? 45. Very good. So we have a 45, 45, 90 triangle. Now once again, the radius of this circle is equal to 1. All the circles, they are all radius 1. So if the radius of the circle is equal to 1, what do I know about this side right here? The hypotenuse of this triangle. 1. Yeah. It's 1. There you go. Cool. So I've got that side. Now, what kind of triangle did I draw? A right triangle, and also it is isosceles. These two angles are the same, therefore this is an isosceles triangle, which means what do I know about these two sides? They're the same. These two sides are the same. So I'm going to label them X. Alright? Now remember, I'm trying to find the coordinates of this point right here. So if I find these sides, what do I find? If I find these sides, I figure out what these coordinates are. Does that make sense to you guys? If I find these sides, I figure out what those coordinates are. So I've got to find them. So it's a right triangle. What can you use? Use Pythagorean Theorem. Good. So go ahead and try and solve for x. It's going to be a little bit different most of the time. Use Pythagorean Theorem. You can use Pythagorean Theorem to solve for x. So go ahead and set it up. Remember, the hypotenuse is always by itself. Figure it out. don't think the radius of the circle is actually equal to 1. Otherwise, maybe. Okay, let's see if we can set this up. What's it going to look like? Well, it's going to be x squared, this leg, plus the other leg, which is still x squared, equals 1 squared. Well, what's x squared plus x squared? 2x squared. X squared plus x squared is 2x squared, which equals 1 squared is 1. What do I do now, class? Divide by 2. Very good. Which then gives me x squared equals, what's 1 divided by 2? 1/2 or 0.5. Very good. Take the square root of both sides. I get x equals, no, because it's a square root. It's not just dividing by 2. It's a square root, which is 0.707. Okay, cool. Hey, that's a real number. Now, for the record, that number goes on infinitely. It's not just 0.707, but it's 0.707106. So we can just round it off there. Okay. So if these are both 0.707, what do I know about the coordinates of my points? My point. What is it? 0.707. You know what's so funny? Every time, I'm telling you, it's clockwork. 30 minutes after lunch is over, the energy level. It's just human physiology. It's just pure physiology, right? You eat your meal, and it's like you're feeling it, you're still active, and then 30 minutes later, the blood starts kind of rushing to your stomach to digest all your food, and your brain's like, man, I just need to chill. That's why they have siestas. Siesta? Yeah, well, some schools have like 2-hour lunches, but then you end at like 4.
Okay, that's worth it. If I get 2 hour lunch.
2-hour lunch?
I would prefer that. And just
Then after that,
you could go home. You could go home.
a 2-hour lunch.
If I had 2 hours of lunch, I'd go home.
I
take a nap.
could go home.
A
I go
2-hour
home.
lunch.
I do the same thing. Lunch takes me 10 minutes. Nap for an hour. Drive back. That's how I do it.
I don't think I would get back
Yeah, you might just fall asleep and I would be in the story. You guys want to try something fun?
Yeah.
Get up. Stand No, I'd like to
It's great.
Okay. Oh man, I don't even know if I can do this. So like, okay, so you take your left foot and then you go like this, right? And then you put your hands up like this, and then you bring it down like this, and then you.
I can do it.
I just can't hold this wheel Amanda's about to do it.
You just gotta get your balance.
Do it. Kai is like,
Got it.
Kai's got it like no problem.
We do some sun salutations. Me too. Some sun salutations.
Kai, now shoot up, Kai, shoot up.
It does all like.
telling you.
Sun.
Super cancer.
Again.
I hate it.
621.
6-4.
12, 16.
16. You know what I say my desk right?
Kai just won. Kai just won.
Stop.
All right.
Steven
It
has
was
something
12.
like that.
Who's really idea?
I'm trying to
6
think.
jobs.
You got any more? You got any
Yeah.
more?
Yeah.
No, he just said he likes ready to put it on. Yeah, show him.
No.
Oh, yeah.
He's okay. Okay. I'd like to see.
Do it.
All right.
Are you doing
Okay.
a
Okay.
I just did it.
Oh.
I was in deep.
Okay. So that was good. Nice job, class. So let's.
How does that fit with that?
Well,
Well, now we're saying you make
I
a
could.
triangle with your
Tell
leg.
me now. Yeah, you make a exactly.
Yeah.
You make a triangle with your leg. It's a 45, 45, 90 triangle.
Hey,
And you-
I want a picture.
Yeah.
Oh,
You gotta keep our track.
And the radius is. Good job, Amanda.
What other tricks
All right.
do you have?
So we found the coordinates of this point. So now we got to move on to our third point, which is actually our easiest. So go ahead and flip to your third page. Go ahead and flip to your third page. They were both 0.707. Now, you flip to your third page, and you're going to draw an angle from the origin to the third point. Okay? And if you had your protractor, you'd be able to see that this angle is 60 degrees. And then you line your straight edge up so that it intersects those 2 points in quadrant 1 and quadrant 4 and draw a line straight down. And then to finish it off, you just go ahead and connect the 2 sides. So you should have a third triangle. Yes?
If you have 2 sides that like equal 1, and you try and use the
Pythagorean Theorem.
Pythagorean theorem, how would that work?
I can show you. I'll show you off. The thing you're thinking of is it's not possible for it to be a triangle. So, but I understand what you're saying. Because you would think it would cancel out, right? Is that what you're saying? Yeah, it wouldn't be possible to have a triangle that would cancel out.
Well, yeah, but like here our radius is like equal to 100.
Mm-hmm.
So if you drew a line between one of our 2 quadrants, one of our 2 axis dots, you know, see the dots on the axis?
Mm-hmm.
If you drew a line between those 2, then you have 2 sides, like one on the x and one on the y. So there and on the other one.
Oh, here and here, like
Yes,
this.
if you drew a line between those 2,
Uh-huh.
so your triangle was
45, 45,
yes.
90.
And
It would
then
be
you
1 squared plus 1 squared equals the hypotenuse.
Yeah, but 1 squared.
This isn't 1. This wouldn't be 1.
Yeah, but like, how would you do that? Because 1 squared is 1.
I'll show you. I'll have to show you offline. It's a good question. I like it. I'll have to show you offline. Okay, so this is 60 degrees. What's this angle here? What's this angle here? 90 degrees. That's 90. So if that's 60, that's 90. 60 plus 90 is 150. What's this angle?
We need 30 more.
30 more angles.
Yeah.
30 more degrees. 30 more degrees. Sorry. 30 more degrees. Okay. So we have a 30, 60, 90 triangle. Wait a second. Didn't we have a 30, 60, 90 triangle before? Yeah. Okay, wait.
Go back 6
Wait.
seconds.
Again, we have the radius is equal to 1. So we know this side is 1. We're trying to find the coordinates of this point, right? All I need to know is the sides, those 2 sides. So go ahead and flip back and figure out what those 2 sides are and label them, okay? So go ahead, flip back to your first page. figure out what those two sides were and label them. Okay, the shorter leg and the longer leg.
The first page?
The first page. The first page it was a 3069 triangle.
360.
Oh, no.
No. This
Oh, I
half.
see.
Oh, wait.
So it's
See,
1, 1,
that's
and
not half.
5, and 0.866.
Yeah.
If you flipped for x and y, the answer is gonna be that's the answer. Oh wait, dropping is not just the answer. Like, John?
Makes sense? Okay, did you guys figure it out yet?
Yeah.
Okay, so what's the shorter leg equal to? 0.5. And what's the longer leg?
0.866.
Good, so what's the x coordinate?
0.5.
0.5. And the y coordinate?
0.866.
Bam! We got it. That's what I'm talking about. Yes, ma'am.
Okay, so obviously looking at that, we can infer that that's a 90-degree angle, but normally don't we have to like prove that somehow?
Yes. And that is very, very good because you totally called me on something that I've just been blasting past everyone. You don't necessarily know that this is 90 degrees, and Jenny's bringing up a very good point. You don't know that this is 90 degrees, but what can I tell you? Well, if these 2 points are truly corresponding, right, they're the exact same angle, then by lining up your straight edge to it, the only way for those to be corresponding and intersect this line is for it to be perpendicular. But I've been blasting that past you guys because it's just straightforward, right?
Right.
But usually, yes, I would have to prove that that's a 90-degree angle.
So is that gonna happen in the future?
No.
Okay.
No. But that was very good. That was very good, Jenny.
Good job, Jenny.
Okay, let's clap it up for Jenny. Good job, Jenny. Okay. All right, so there we go. We've gotten our 3 points now. So go ahead and go to your 4th page and label all 3 points that we found on that 4th page. And this is the one that you want to keep neat, okay? So you're going to label all 3 points on your 4th page. So like this point, and this point is what we solved for already. So label the coordinates of those points. Because the first 3 pages you found the coordinates of those 3 points. So now you're putting them all on one. So you're going to label the coordinates of this point, and this point, based on the work that you've already done. You don't have to draw your triangles on this one. Just label the coordinates. All I'm looking for on this last one is the coordinates. What are the points? So go ahead and label those 3 points, please.
You have an isosceles triangle where the 2 sides that are equal are longer than the 3rd side. Is there a way to find the 3rd side?
.707, .707. Mhm. Okay, so you should have gotten that at this point this is .866 and this is 0.5. These are both .707. And this one is 0.5, 0.866. Okay, so those are the 3 coordinates. Those are the coordinates of those 3 points. Now, the next thing we're going to do is find the coordinates of this point and that point there. So I want you guys to think about that while I'm plugging in. Again, the radius of this circle is equal to 1. So how could I find the coordinates of this point and this point? That's the question. Well, let's take a look. Let's take a look. Okay, this point here, is it up or down at all? Is it up or down at all? Oh, it's right there on the x-axis. So what's the y value? What's the y value at this point? 0, right? Yeah. So it's 0. So we know the y coordinate is 0. And if the radius of this circle is equal to 1, well, what's the distance from here to here? 1. So what's the x coordinate? 1. Very good. And similarly, this point here, is it to the right or left any? No. No. So what is it? What's the x coordinate? 0. Good. Good. And what's the distance from the origin to the point? 1. So what's the y value? 1. Bam. You did it, guys. So, all right. So, are these all the points on the circle? No. Okay. So your task now, and your homework, though you can honestly get it done in a few minutes, if you can kind of see the deal. Remember, this is quadrant 1, 2, 3, 4. Your task is to find the coordinates of all the rest of these points. That is your homework. That is the entirety of your homework. It's to find the coordinates of all these points. Remember, this is 1, 2, 3, and 4. That is your homework. Same. So remember, guys, all these points are at the same angles, right? So that's, you have to know that they're not just like arbitrarily drawn. These are all at the same angles.
That's what he just said.
There you go.
Which one's positive?
Well, you just gotta think, right? Here's the x and the y.
Is it like a
He
regular
said that, but I don't
Yeah,
know.
exactly. Exactly. Yeah.
But then which one?
So here's the positive x-axis and the
I
positive
get it, I
y-axis.
get it. So when you write it,
No, Charlie. You now, good boy.
when you write it,
No, Charlie.
Why don't you?
the x would be negative, the y would be positive, the x would be negative, the y would be negative. Did I figure it out?
Pushing.
No, I'm just going.
Charlie's
You're just figuring it out.
Charlie's hand.
It's not something to joke about.
Oh, they were supposed to give it to you yesterday. But you weren't there. Still missed that. Oh, hey, Charlie. No, just kidding. She took it. So maybe she'll give it to you next fall.
My boy.
So wait, is it, you think I reflect this? Why anyways, everything this time should be so like X.
I think it goes.
This is very
I'm so confused.
Yes, I really hope.
This is negative 1.
Yeah, that's okay.
This is negative.
So wise. It's always said it's better.
So this is expected.
Or it'll be negative. And I'm saying that's all. I hope he finds
It would be to the right is positive, so your x would be positive, and then your y would be negative. You know, like when you graph it? Okay.
Yes.
Or like graph it. And we had it plot like. So this would be positive, and this would be negative. Yeah, the y would be positive if it goes up. Okay, I think I get it. You're welcome.
Cut someone.
Then I go back to Jenny, right?
You just. I thought she liked the first one.
So, you guys have 5 minutes. 5 minutes left. But to close our lesson, though, it kind of just sent you off into your own worlds. To close our lesson, I want you guys to think, but just place the question in your mind. What does this have to do with trigonometry? What does this have to do with all the things that we just learned? I'm not necessarily going to answer that question, but it's a good question that you can have in your minds for now, so that when I do answer it, you can be like,
Ah.
So good job, guys. That's it.